Hello and welcome to episode 4 of Building a Smart Farm. I'm joined again with Gabriel Koch of Agro Patterns. Last few weeks we've been building up our smart farms capabilities. We used Firebase for storage in episode 1. In episode 2 we ingested sensor data from Blue Wireless sensors, so we've got live data, real data in the field being streamed into our Firebase. In episode 3 we wanted workers to be able to request data visualizations on demand, and that was episode 3, sending data over WhatsApp. In this episode 4, we would like to be able to do some SQL analytics on our data. So actually process the data, set it up to make decisions. Gabriel, what's the kind of decisions we might want to do?
Well, it's really important to look at minimum temperatures, the max temperatures, and the average in the greenhouse, for instance, for the duration of a production cycle. Let's say that we have a 3-month cycle for chrysanthemums. So knowing the minimum, the maximum, and the average is important. Also, I think in the first episode we talked about growing degree days and calculating the number of hours since you planted something until it's harvested. Every variety has a different number of growing degree days, which is it's really counted in not in days but in hours, that under a certain temperature and above a certain temperature. So it is my hope that with what you have in mind, what you have cooking there, we can do that.
Yeah, so this was one of the charts we did in episode 2. So we've got these sensors coming in, and then we can we use observable plot to chart them, and this green band was the growth zone. I see there's some new sensors come online as well.
Well, that's correct, and that's my fault. Yeah, I created a dummy sensor there, so that may have generated some.
Yeah, it crashes when we do that. We haven't done, we skip through this stuff quite fast, so clearly, we've accepted some data that crashes the dashboard, but the other ones work. Okay, so, the great thing about observable, we can just fork where we were last week. But let's start a new episode. So we're on episode 4 now, and this is going to be DuckDB, Firebase to DuckDB. And this will be using the new SQL cells that Observable has. So I don't have much experience of that. They're quite a new feature. So let's give it a go. I'll tidy up this dashboard later, but let's actually have some data out of it. Where was the data? Here, let's make sure we've got data. So this comes out and writes to query sensor name, and then we can see 1 day's data there. Mm-hmm. So we're using Firebase for storage, and when we got the data in, we issued this query where this is the Firebase SDK. We've got this specific path in our database. Let's have a look at the database. In Firebase, we have in our real-time database, so we can look at the data in real time. We have a history for all our sensors. These were the sensors that we had, and under each sensor, according to the timestamp, the second since 1970, so it's ordered chronologically. We put the Blue Wireless data, which has lots of interesting payloads. Body is quite an interesting one because that's where the sort of sensor-specific data comes in. There's a battery. There's a button on it. What happens if you press the button?
Well, you have to turn it off, right? I mean, if you send these sensors to other places, if it didn't have a reset button or an on and off button, you would you drain the battery. So
it's interesting though. This button's actually sent out on the wire, so we can see when someone presses whatever is the button. It's only got one according to this, or only one is serialized. Anyway, so these are the payloads we get in the real-time database.
Well, you're at. Can you delete that first sensor that I created? Maybe it generates some noise. Yeah.
Okay.
I don't know.
Yes, we can do that. So throw that.
Thank you.
There's also the current. When we write data, we write in the current and delete the current. So we've already got these. And your telephone rings for some reason at the same time.
No, I'm so sorry.
When we get this data, it's loaded by this query. So this is the Firebase SDK. We reference the query, the part of the tree of data that we're interested in, the name, the sensor name that was selected. We order by key, so it's chronologically ordered. The key in this case, timestamp. We tell it to start at 24 hours ago, and then we query by value. And what a value does is it means it gets all the data at that location. First thing we want to do is load it into DuckDB, right? So let's just find what DuckDB is. So DuckDB is a WebAssembly. WebAssembly means you can run it in your browser. This is unusual because most SQL databases, they're appliances that you run on dedicated machines like Postgres, and your application connects to it and it's held elsewhere. But what's interesting with DuckDB, the WebAssembly build, this can run inside a browser, so we get to avoid having to spin up a separate box. Of course, like as a result, this is kind of underpowered. It has less memory, less performance and such like, but it's extremely convenient for us where we're using these client-side technologies like Firebase. And the issue with Firebase is it only has these very simple key-based queries, order by key. You can only order by one thing. You can't do complex queries on it. But DuckDB supports full SQL, so you can do SQL queries, and it can be embedded client-side as well. So these two things are going to go together pretty well, I think. And that's the purpose of this live stream, is to like show you how to do that. So DuckDB, you can sort of import it at the low level, but this is more convenient, is to import these observable clients, and then it works with the new features we have. So this is the beginning of our DuckDB. We need a client, and what happens if I build it without new? I think I just go DuckDB equals a new client. And what's really exciting about this client is it works with these SQL cells. So new cell type, a database query, and I can select the database. I can look, it recognizes databases that have been instantiated in the notebook. So the database we want to query is this one that we just created here, DuckDB by name. And now I can just type normal SQL, select star from readings, and if I execute that, shift enter, yes, if I execute that, no table, well, because we haven't loaded the data. So now let's load the data. So our Firebase can be queried by time, so we can get a block of time, and we want to load that into the database. So I think if we go back to here, so here's an example. Oh yeah, first we have to create a table, then we can insert values. So this looks useful. So let's go create table, or let's call it do create table, because it's an action with a side effect. And we want to create a new create table reading. We want to create a table using our client that we instantiated upstairs was DuckDB. Create table readings, and what are the fields that we want? We want the sensor name, and we're going to be calculating the growth days.
Growing
degree days. How do we calculate that? What do we need for that?
Well, we need to make sure that the temperature that it is read is
temperature.
Yeah, it's, let's just say, under 30 degrees Celsius and above 4 degrees Celsius.
Yeah, and the other thing we need, so we need the sensor name, the temperature, and the time that we read it. So let's just, I think it's called a timestamp in SQL. Is that right? Let's see if that works. Maybe. Now what happens if I run this? Yes. So now when we do select star from readings, because we created the table, we got it, but it didn't error, but there's no data in the table. So that's kind of like step one is we created the table. And now step two is we've got to actually load the data. So this would be this bit here. So we could either just load everything in here. The problem is that in 15 minutes time, when that sensor updates, this whole cell will reevaluate. So if we just sort of blindly iterate that and put it into the database, then next tick when more data arrives, we'll end up duplicating 99.99% of the rows, and we'll put the new one in. So instead of doing it all in this kind of bulk way, what I would like to do is do it one row at a time. And we can kind of do this. So instead of doing a value query, I'll show you working with lists of data. This is what's happening. Child added event. This event is triggered once for each existing child, and then again every time a new child is added. So if you do a child added query, it will first of all fire umpteen times for each child in the place you're listening to, and then as new data is added, it will fire just once for each row. So this gives us the one at a time behavior. So we're going to change this to child added, and now what's happened is it's fired 1,000,000 times, but the last one is the last piece of data it won. So it's useful that we're notifying the result of this, but this is now at last analytic row. So this is now just a single row, but it's fired lots of times, and we want to pipe all that data and insert for each one of these bits. We want to insert it into the DuckDB table. So creating table was kind of like what we had to do first. Now we're querying for rows, and we're going to use the flow queue. What we're going to do is put all these elements into a queue so that we can process them one at a time without loss. And we'll call this a Firebase row equals a new flow queue. These things have to be processed within a certain amount of time, otherwise it decides that something's gone wrong, because it kind of queues things up until they're explicitly acknowledged. So, but I don't really want that behavior, so we'll just put a huge timeout so that we can process these things when we like. So that sets up a queue. If we look at what the value at the head of the queue currently, it's nothing. And we want to put that data into the flow queue. So what did we call the queue? Firebase row. We're also going to send it that data. So every time this fires, this will get piped in there. Okay, so now if we look, this should have the first item, which has a time. Well, actually, if you look at the body here, look, this body is a Y payload. So if we actually look at the details in the Firebase data, sensor, the middle one. So some of the bodies have battery and temperature, and that's good. But then some of them, this one, look, this one just has a Y. That was because when we sync with Blues Wireless, we put no filtering, and we got all the types of events sent by that sensor, and some of them are not actually data collection events. So this is, God knows what this means, but we're not interested in, that's not something we want to put in our analytics. So probably we should filter this out a little bit. So if data dot body dot temperature, if that's not null, we don't want to deal with it. So let's change that. And this queue still sees. So if we reset that, the body, if we run that again. Yes. So that filtered out that weird payload. So now we've got only data that has a temperature are we putting into this queue. And then the first element of this queue is this big object. This is the sensor data that's come out of Firebase. Now, this is now one row at a time because we put it through a queue. Now, the next thing we want to do is to insert that Firebase row into our DuckDB client. So let's create another side effect based cell. Do insert row to duck. Right. And we called ours DuckDB. So we want to do insert into readings. We've only got one row. And right, so we called it was the sensor name. Do we have the sensor name? Yeah. Yeah, device. So the name is the device. We can use the Firebase row dot device. And then the next thing, let's look at our table. It was sensor name, temperature, and time. Do you know what? I'm going to rearrange these because I would say time is more important than temperature. Like, this is the kind of thing we're probably going to add to it afterwards. I would say the primary key is the sensor name followed by the timestamp. These are the most important thing. If I return this, yeah, look. When I execute that query, table with name readings already exist. So we can do create table if not exist. That works. But actually, probably what we want to do is also drop table if exists readings. So we want to delete it and then refresh it. Yes. Okay, now if we query it, yeah, sensor time temperature. That's the right way around, I would say. You know, you regret these if you do them the wrong way around. So insert the row. It starts with the device ID. Then we need the time. What was it? Firebase row when, I believe, is the time, and the temperature, which is the Firebase row dot body.temperature. See if that works. Looks like it worked. I would question it because we didn't actually return it. No. Error, unimplemented type for cast, integer timestamp. So I think it's complaining at this one because this Firebase row when, look, the nice thing when we've got it set up in this flow queue, we can inspect what these things are. So this is a number, but this column is a timestamp. How to insert timestamp data.db. Timestamps can be created using the timestamp and must be formatted according to ISO 8601 format, which is quite a classic format. So we've got to convert this to that ISO format. So we've got seconds or something since 1970, so we can do this with JavaScript. If we instantiate a date, this says the date is 1970, so this is wrong. Usually it's like divide by 1,000 or time. There we are, 22 of June in 2022, so that's correct. So we have to take the when, times it by 1,000, now create a new date, and I believe if I just call this date, well, let's see what happens. Let's try and insert this. So we wanna, this is what we think it will be. But then when I execute it, when it expands this, stringifies it, it expands it to this central Berlin time and all that. So this is not the end of the story. We have to explicit to ISO format. I don't know what it's called. So if I just store it in a variable, when I do that, I can now get the IntelliSense to figure out what the special ISO thing is. To ISO string, that was the one. Okay, so that's what I was missing, I think. Can I just call it like that? I think it needs to be in parentheses, let's see. So we'll do little quotes. Yes, there we go. Okay, so great. So we return the query, so we get to see if it errored or not, and it did seem to work. So that's the main step of our queue. Now we can tidy this a little bit. So we have a row coming out, we inserted it. At that point, I would say it's processed and we can tell the queue to click on to the next thing. So, you know, you can always find out what the API is without looking at any documentation. So this is the API. We have this resolve method to say we're finished. So this is like finish processing, finish insert. What we want to do is take the Firebase row and resolve that. And we want to resolve it after this one completes successfully. So we want a data flow dependency on that. Every time we right, click enter, and it's done. And now you see it's all lit up. It was going crazy for a while, and now it's exploded on something. Now it worked for a bit. Let's see what happens if we query now. Yeah, we've got 88 rows in the database, but one of our inserts went wrong and it said range error, invalid time value. Luckily, when this crashes, it doesn't finish. So now it's crashed at the problematic row, which would be this one, and it's saying this bit is not very well. So what's happened here? So we'll just inspect what that thing was. It's undefined, what's even in the row. So for some reason, yeah, look, there's no when on this one. That's funny, isn't it? Why has that happened? That's the only payload that doesn't have a when. Well, what should we do in that situation? Look, we've still got the tower when. Should we default to that?
Yeah, why not?
Yeah.
Yep. It's probably very similar anyway.
So if there's no local timestamp recorded, we can that's how we can say if that evaluates to null, this lazy OR will evaluate this side, and hopefully that'll work. Yeah. Oh, and off it goes. You see, this is it. Boom, 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 boom. Inserting data. Wow, that's a lot of data. Okay, so how much stuff? 500 rows. I was testing this out this afternoon and I was only getting like 100. So what is quite useful to do, especially during development, basically we want to delete everything and start again. So, you know, one way we could just sort of check what happens when we refresh the page, because this will fetch everything fresh. So crashed on, maybe it's just the wrong sensor. Cannot, okay. Yeah, one of the sensors it doesn't like. Actually, we should move the sensor chooser, we need that. And when we execute this, oh yeah, we've got all the data. Oh yeah, 90 rows. This is more what I expected, actually. So I think maybe we ended up triggering we just ended up inserting umpteen times. But I would still advise, instead of me having to do a full page refresh, which is quite expensive, especially when we've got all this old stuff on it, I would say it's a good idea to create a cell explicitly for refreshing, starting from scratch. Let's call it reset. So we'll create a mutable value called reset, and we'll create a button for explicitly resetting, something we can press. And all that does, its reducer function increments the mutable. So when I hit reset, you see this number goes up. Beep, 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 beep. And now that can stay. But what we want to do is make this dependent on resetting it. So it will recreate the schema, and then we'll also make the query dependent on reset, and it will do the data loading again. Oh, wait a minute, it was still executing stuff then. What's happened now? Has it done more? Oh yeah, it probably has done more so let's see what happens. If I reset it, did anything? Actually, we'll also reset the queue state as well, I would say, because there might have been stuff jammed in the queue, so that will change that as well. Let's try again. So if I press, so when I click reset, we should expect it to load again. What have we got? At the moment, it's got data in it. Let's just, so we can actually see that it does something. Drop table readings. Execute. Okay, so let's start from readings. There's no table. Now we'll reset it, and we should. Oh yeah, it flew past. It went really quickly. I think it's doing it so quickly we don't see it. Now if we re-execute it, we've got the data. That's cool. What would be nice is if this table refreshed as well when we reset it, right? Because at the moment, I'm having to keep re-executing this. So there's a little trick to doing this. We've got our DuckDB client, and this is connected to the DuckDB client. There's no simple way of me, like in other things, I was just putting the reset variable in these cells to make a data flow dependency. So if reset changed, this was recalculated. You can try and do it here, but then it tries to create like a SQL prepared statement with a variable, and there's no real way around it. Like, it doesn't like that. So you can't do it the way I was doing it here. For this one, we want this cell to refresh. So what we can do is create full duck. And it's exactly the same as the DuckDB. So it's the same variable reference, but we'll just have it a data flow dependency on the reset button. So now when we hit reset, this cell will reset. And now, instead of depending on that client, we'll depend on that client.
Hey, Tom, let me ask you something about the reset.
Yeah.
From our user perspective, it would make sense to see, for instance, the last 48 hours. Would that be included into the kind of the flow of the app? It's just the analytics are only applicable to the last 48 or 72 hours, or let's say the last week or whatever it is. Would that be a good use case for the reset feature that you just coded?
We can, yeah, I think we'll do that as a separate button. Yeah, I think we need to be able to adjust the time window, and we'll do that. Yeah, so I think we'll come to that. Like, when we're developing our analytics, like if we try and do the full, let's look back a week, it will be slow because we have to load lots of data. So we'll try and get our SQL queries working on just a day, and then we'll figure out how to make it bigger later. Okay, I just pressed the reset button, and I'm surprised to see that now this is empty, and if I press enter, yeah, it's done, because what's happened is it's reset it, displayed it before all this stuff has come in, before it's actually done the insert. So we reset it. So at least it works to a degree, but really we should be refreshing this as new data arrives. So remember, these are live queries. The thing about Firebase, this is a live query, so data will be arriving. So yes, we have 88 cells now, but we'll have 89 later. So not only, so it's not enough to be dependent on the reset button. We also need to update that every time we insert a new row. So let's say that depends also on the do insert row. And now let's see what happens. Presenter. I mean, it looks good now. Now what happens when I reset it? It pauses and then it comes up with all the data in it already. So this is cool. So this will completely throw away our database and recreate it from scratch using data loaded from Firebase. So this will keep our data quite. So this is useful for development. We'll probably have to press this reset button a few times, but now we have a nice workflow set up. So now we can like get on with the actual like interest and analytic. Now we've taken our Firebase data, we put it in DuckDB. We can adjust the schema as we need to. So now we need to actually do something useful with this data. So we'll try and calculate our, what was it called? Growth days.
Growing degree days.
Okay, so this is a new section. Now we're gonna do the actual analytics. Growing degree days. DDD, cool.
GDD, growing degree days.
Right. So what the sensors report, the name of the sensor, the time the data was collected, and the temperature. How do we calculate GDD? Any ideas?
Is that a question?
Yeah. Any ideas?
It's any temperature above, I'm going to say 4 degrees is useful, and any temperature be under 30 degrees is a valid record for calculating this.
Yeah, and we have to integrate that over time, right?
Mm-hmm.
Growing degrees days. Yeah, it's degrees times by days. So there's like an integral overhead. So the problem is like when we actually look at the sensor data, there's gaps like here. So like we measured a temperature here.
Mm-hmm.
You know, ideally we're measuring the temperature every 50 minutes, but we can't actually assume that in reality that's happened because occasionally there's gap stuff, and that's just the real world by.
Mm-hmm. Yep.
So to deal with this, like we've got these point measurements, but we need to actually consider the duration between each measure as well. So in order to do that, we have to look at the current point and the previous point, right?
That's correct.
So this is when SQL goes mental immediately, quickly, because it's. I find this quite tricky to do. So what we and then the temperature is not like the current temperature. Probably maybe you want to take the midpoint if we're doing it right or something like. So how do we do that? I wonder.
Can we get the? Well, this may be unrelated. Could we get the average over? That may be a completely different question. So I'm not going to go there for now.
Okay. DuckDB. So there's things in SQL window functions which hurt my brain. General available window functions. Actually, the first one is row number. Does this work? Let's try this. So yeah, window functions, they're complicated. So let's start simple. So we haven't lost this. I like this table. So this is going to be like our new experimental table. Select style from readings, right? It's going to have to be ordered by time. That should work. Let's lay this out a bit nicer. Oh, is it funny? I decided to insert that. And we also want the row number. Does that work? Scalar function name row number does not exist. So is there any examples? Look, here we are. Select the column names, and then here it's just called row number. Reference column row number not found. Row number. Okay, from history, from readings, order by. Okay, maybe. Okay, select sensor time. No, I played with this offline. I could never get that query to work on the WASM one. So oh no, it goes row number as row. Yeah, I can't get this work. Order by. Oh, I can't get this to work. Anyway, okay, can't get that working. So it's maybe not that important, but it's useful to know that SQL does understand ordering. If you order stuff, a window function allows you to walk along the result set, and the simplest is the row number, so it can just count as it's through the result set, and you can use that number in further calculations, which is handy. That's like the easiest one. And then it goes on to talk about framing. Framing specifies a set of rows relative to each row where the function is evaluated. The distance from the current row is given as an expression as either preceding or following the current row. So this is interesting where, in this example, they select points from their results. So their results has a set of points, but then they sum a load of extra points, and this is where they introduce this over keyword over the rows between one preceding and the one after. They add how many points. So let's see if we can get this thing working. We'll just adjust it to our names. So we'll select the sensor and the time from our readings, and we'll sum the point. Okay, we'll sum the sensor over rows between one preceding and one afterwards. Let's see if that works. Bind error. No function matches the argument sum var car. Oh yeah, because this is trying to do an arithmetic sum, and sensor is a not a number it can add up. That's fine. We can count it instead. Does that work? Ooh. So what is this input? So this was the row it was currently processing, and now it's got this called what should we call it? Our window function is either 2, the first row is 2, because on the first row there's nothing preceding it, and there's one following it, plus it's itself. So it's counting how many elements are in that sliding window as it goes over that. Should be ordered, which I've not. Order by, so we would normally order it by time. I don't think that makes a great deal difference. Oh, for some reason these are only 2. No, it's interesting. It's not doing the window function in the order I specified. It's doing it by its own thing. So that was the simple example. Like, certainly I can see some of this. So now let's look at a more complicated thing. The point is, this one here, the sum bit is like some kind of aggregation. And so it's doing a computation over this window. Our window is one before, one after, and it's like a window is dragged over it, and then we can do a computation over it. So that the computation we might want to do is take the average. We want to take the average temperature of the things before it, and we also want to know what the value of the time was of the one before it. So if we look at this more complicated example, they take an average and they do the over. This is the window function. You can partition it, but do it over a range and order it. Yeah. Okay. So what we want to do. So instead of one following, I think we can just go rows one preceding. Does that work? Yes. So now everything has one row except this one. So now so the window function is the row itself and the one before. That's what we want, and we want the average temperature. Okay. Mm-hmm. Right. So that's average. That's our new temperature actually. Well, is it? Well, let's call it average temperature. Okay. So the temperature is the latest reading. Average temperature of the one before. But we can do more. I think we can do more than one thing. So we can also do the mat time, that's the end time, and we can do the min time, that's the start time, right? So start time 13:42, end time 39. So have I done that the wrong way around? Oh no, it's just these are printed the wrong way around, they're confusing. So the start time is on the this is a completely different day. This one's on the 16th and this one's on the 28th. So this is not ordered properly, that's for sure. This order by time is not being taken into account at window. So I wonder, order by. I think the order by has to be internal. Where is it? So it goes over, the order by is just before the rows key. Is that what I need to do? Over, does that still work? Yeah, okay. So if I do it like that, what happens now is, yes. So the start time is 13:42 and 6:36, and the end time is exactly the same. Yeah, because this is the first row, so it doesn't have a different end time. This one, these all look like exactly the same time. Oh no, this one's different. Yeah, 13:42 to a completely different day, 16:52. However, this is the right ordering, and then this is the 27th. I wonder what's happened here. Why is there day from the 16th coming into this, and this is the 27th. What's today? The 28th. Yeah, we shouldn't be expecting any 16th data.
Well, it could have been that the sensor was turned on then and then turned off for a couple of weeks. I mean, there's...
Yeah. Do you know, I think this is a mistake we made when we did the ingestion pipeline, that we ended up saving the data using the timestamp from the cellular tower rather than when it was recorded. So we've got like a data mistake in the way that it's persisted in the Firebase. So we would have to rewind and correct or rewrite this data because we used the wrong primary key. However, this actually looks like it is working now because everything's before, and once it's in a range where it was, things are very close. I mean, a lot of these look like exactly actually this is like, these are repeat rows.
Well, they should be the same day, but slightly different time, right?
Yeah, this is the date, and this is the time in hours, minutes, seconds, but there's like 3 payloads here, 4 payloads of all exactly this. How many rows? 600 rows? Oh, we've made a mistake here, yeah. I think, we seem to be, every time a new data point arrives, there's 600 rows, now there's only 89 rows. Okay, and now, is this updated again? Yeah, this is updated and it's okay. So somehow we are doing duplicate inserts. Right, there's another thing you can do with window functions. If you look at here, most of this is the same window. So when it says it here, window clauses, multiple different over clauses can be specified in the same select. Each will be computed separately. Often, however, we want to use the same layout for multiple window functions. The window clause can be used to create a named window that can be shared between multiple window functions. This is the situation we just want to save ourselves typing this load. So the window comes after the from, before the order. After the from, before the order. So window, what should we call it? Look back as, not a partition. So it's just the insides of this. Order by time, 1 rows preceding. And now we can hopefully just go. And then all these things will be computed a little bit more efficiently. Does that still run? Yeah, so that's fine. So we've got the average temperature, the start time, the end time. That'll be what we use to actually do this integral over time. We've got the start time and the end time. What we want to compute is the duration, right? What I would like to do is just go end time minus start as duration, but I don't think it will like that. Reference column is not found in the from clause. You can't do it on these computes. So the way to do this is we'll just select start from what we just already computed and bang this down an indentation level, and it doesn't like that semicolon. Do we need the semicolon? We don't need the semicolon. So now this is exactly where we were, but now we can reference those columns that we'd computed in this inner select. Now we can use them in the outer select and do computation. Yeah. So this is a duration, looks like microseconds or something. And what's the other thing we need to do? Now we need to decide whether, so this row now describes an interval, and we know what temperature it was and how long that interval was. So like this first record is useless because it's got duration of 0. So the mathematics will work out that this temperature won't be weighted. This one will be. What's the next thing we need to do? Is need to decide whether it's a growth day or a growth.
Or no.
Yeah, is growth. Ah, look, 216 rows just happened. Right, so our bug just got triggered. I know what it is. Not only did it, because we only had 87 rows or something. This is not just inserted it 1 extra batch. It's done umpteen extra batches. So what's going on here? I think what's happened is we've got some code we wrote at the beginning is still alive and running in the background because we didn't tidy up properly. So where's our query is here. Yeah. So what's happened is we are not tidying up after ourselves. Firebase database unsubscribe. Yeah, our live queries, we issue these live queries and we're issuing repeat live queries on our same data. So they're like building up so that this problem's getting worse over time. Unsubscribing for the Firebase database. You should always remove listeners when that listener is no longer needed. And what happens with observable is a cell refreshes, it reevaluates, and we attach another listener, and we're stacking this problem. To remove a listener, use the off method on the same reference that you use the on. Thank you, Doug. On. So we passed it a listener, and we have to call off that. So we'll call this the data handler, and we'll just capture that there. So this is now that data handler. So this is exactly the same thing we did before, but we also, when the cell refreshes, this is an observable concept, is they give you this invalidation promise, which is something that executes when you want to tidy up resources. So this is what we want to do, and they say just do the same thing. I think all we need to do is just do it this way. We just do it on the ref. We'll turn it off data handler. I'm hoping we don't have to do all that stuff. Right, and now, because we've got stuff in the background, this is worthy of a page refresh, so we'll reset our state. Fingers crossed, and we've got to choose the right sensor. I don't think all the sensors were working. 89 rows. So that's our classic. That's where we are. And I tell you what, it's always hard to know whether this invalidation bit worked or not. So what I do is have a look at the console. So when I refresh this will run. If it doesn't like it, it'll complain. Oh look, there we go, it did complain. And now it's rejigged everything. Uncaught promise, query event argument must be a valid event. Oh, sorry. Yeah, you need to do it in the same way. So good job we checked that. Now what happened? Right, I think it's running the previous bit. Now let me see what happens if I run it again. Yes. No error thrown this time. Some other errors, I don't know what they are. I'm going to ignore those. Now we're back to the position where we have, how many? We rerun that 300 rows in there. Let's reset that. See, it's very handy having this reset button. You'll be pulling your hair out otherwise. So we reset it, and now we're back to 89 rows, and fingers crossed, things should be going in one at a time, how we originally planned. Yeah, so we just forgot to tidy up. We had these live queries just growing. Okay, so back to our SQL here. We're trying to calculate whether it's a growth duration or not, and that's based on temperature. So how do we calculate that? That's if the temperature is over, what is it, 5 degrees?
Let's just say, 4 or 5.
I want it aligned with our earlier table. 5 and 25 is what I've got. 5 and 25. Yep. So if it's over 5 and temperature is less than 25, we say that's gross here. I'm going to reduce some of the columns here. It's getting a bit big. So now we only care about the sensor. We don't care about the time because we've got the start and end time. We don't care about the temperature. We care about these calculated fields.
Very interesting is that it says that what is it, 75% of the time is growing, or is that correct? Am I reading that correctly?
Yeah, exactly. Yeah, so this is one of these great features of these SQL cells, is it gives you a little summary of the column as well. So we see the temperature range is average temperature range, and it tells us, it summarizes this is growth and says that 75% are, I guess, true. What does that mean agriculture-wise? Is that good? Are they doing well, or is that bad?
No, it's not very good, right? 25% of the time the flowers are not growing.
But this would be at night, right? Are they expected to grow at night?
Well, that's a good point.
Yeah, if we ignore the lower bound and say if the temperature is less, it's 75. It's because it's too hot. You're right. So what they need to, I guess they are growing at night. Are they? Do flowers grow at night? I don't know.
They do. I mean, they do some, and in some cases they have artificial light as well. So they trick the flowers into growing constantly.
Yeah. Okay. So now we know the duration. Now we have to sum it up, right?
That's correct.
So let's keep this here, because sometimes if you just keep adding stuff to a SQL query, eventually it'll get so complicated and one day it won't run properly that you'll have no clue how you got to this monstrosity. So I this is a nice thing. We just duplicate this cell. This becomes documentation for how we're figuring out these growth days. So we want to select star from, again, I do that trick I did before where I just you know, nest just another select statement there. If I execute that, that's where we were. We'll add another one called growth duration, and this is a calculated field of, we want to take, so this is where we want to do an if statement. So in SQL they have these case, when something, then something else, the default, and you've got to end it in end. So we've got case when, and the expression is a boolean. Well, that's easy because we already had a boolean. When it's a boolean, then its value is the duration. What was the default called? Else. Our default is the value is 0, yeah. And then we close the clause, and we'll call that growth duration. And now there's nothing there. This is not really a 0. This is an interval. 0 seconds. That was confusing. So I think we confused it by sometimes we return it. This is an interval because it was a 2 times subtracted. So that's not really even though it displays it as a number, even though it looks like a number here, that's really an interval. Yeah, it's a shame actually. Look, this one says number, this says string. Duration, it should really say interval here because it's not a number, but it looks like a number. But yeah, mixing a number and an integer clearly is. So that's the growth duration. So it was 0, 0, except in that case. Okay, and now we want to, let's keep nesting those. Select start from even more complicated thing. Yay for SQL reusability. Oops, star. Yeah, that's still going. Right, and we want to select the sensor and we want to sum the growth duration. And now this is not going to work, I think, because it will say no such thing as, you can't sum intervals, so that kind of makes sense. So we'll cast growth duration as integer. Does that work? Yes, it does, but we have to also add a group by sensor here. Can't cast an interval to an integer, so it doesn't actually know how to convert between a duration into a number. And I think I'm using the wrong thing. It's not a cast, it's an extract epoch from growth duration, is it? Like that? Ooh! Bit weird, these commas here, which is partly going to be, oh, maybe that does make sense. Right, so sum that. I think this is now an integer. Yeah, so now we want to cast this to a float, and we want to divide it by, so what do we want it in? Hours, you say? Or days? Hours. What number is this? Okay, well, you know, I can't figure it out right this second.
Yep.
And then you were asking, right at the beginning, can we do it for more days? We're still stable on the amount of rows. It's nice. Can we increase the amount of data? So here, what we did last week is looked at 1 day before, and what we want to do is look at how many days before, a few days before. So choose the sensor. So what we can do is go inputs.range. How many days do we want to look back? But at least 1 day, up to 10 days. Label days to look back. View of days look back. And I don't like these partial decimal numbers. So we want it to step in increments of 1. And I don't like it starting at 6 either. Let's start it at 1. Okay. And now, instead of looking back by a fixed amount, we want to look back by number of days we're looking back. So this will rerun. What happens when we look at 5 days, and we should probably reset it. I'm going to reset it as well. So this is it loading it. Now we've got 400 rows. And look, this is what I was saying where DuckDB struggles a bit. Because now we've got an out of memory error. We could not allocate blah, blah, blah. It couldn't do those window functions because we've got too much data in it. So these are some of the limitations you're going to run into, which is a bit annoying. So if we do 3 days, reset it. So it's interesting that it can load the data. So the data goes in the database, okay. Now we're only doing 3 days. But then when it tries to do this window function, it doesn't like it. So it's this function is failing. 2 days in the past. I don't know how many days it can look in the days, but it's more than one. And then we're computing the growth hours. Actually, let's write back into the database because we haven't. We'll call this the aggregation.
Could we then extract the data from like we're doing right now? Use DuckDB to run aggregations and then push the data back in to Firebase. Am I understanding that correctly? That's what you're doing.
Yeah, exactly. Because as you can see, this DuckDB can't handle a lot of data because it's all in memory. So there's different ways we could solve that issue. We could add a persistent backend for DuckDB to use as some kind of like scratch space. But I'm not even sure how easy that's to do when we're running it in the browser. Or maybe what's simpler and what we do here is we'll do little chunks, compute little windows, daily windows, and then write them back into the Firebase database. So that'll be so we're never computing too much data. Like for predicting when the crops are going to be ready. Then we just add up the daily total as well. So we'll pre-aggregate, do lots of like mini pre-aggregations, and then build it up. So we need to know the date. So I'm just honing in on this. Yeah. So if we store it under that key, a date. So that reference, we can set it to be. I'll just put it as the aggregation there. Permission denied because we don't have rules set up for that. So just for the sake of doing it. Oh, we allow reads if you're non-anonymous. So we need to log into Firebase. Have we got the Firebase? Yeah. Auth, yeah. That's auth dot sign in anonymously. Okay, now let's try it. Did this, okay, so it looks like it wrote. Right, and now we've got our database has this extra row, and it's under the sensor name, the date in a day format. Oh, maybe we shouldn't have done it like that. So it's actually it's nested it and put all this extra stuff. We want the window analytics. So the reason why it's saying sensor is because we printed out the sensor here. I think we'll keep that for now, but we meant to set it to that. Let's see, so we rerun that. And now when we look at that, yeah, okay. So now it's putting in the growth hours, which is a nonsense number because I have not figured out that formula yet. But it is an aggregation over the sensor data we collect. Yeah, so should we push on? How are you doing for time?
Oh, we're probably time to kind of wrap things up. I think what's really important is being able to extract it to do some analytics, create a like secondary. I'm going to use the MongoDB naming conventions, although I know it's not right, but like write a different document in a different collection, the aggregation collection of sorts, and then that aggregated data is going to be used in the future to do more graphs, historical data. Does that make sense to you, Tom?
Yeah, exactly. And what I think we're missing to like finish this work off properly is this needs to be done on a schedule as well. So we have to schedule this aggregation process to occur. Now you might say once a day, but if you schedule it once a day, it's a little bit risky in case it doesn't run. So for these kinds of daily jobs, I schedule them every hour. I check in the database, have you done your aggregation today? If no, do it. If yes, okay, just do nothing, tick. And then that gives you 24 chances to actually successfully do your aggregation. And it'll be doing it within an hour of it being possible, right?
Would it also be possible that as data comes in, if you run the aggregation kind of on demand, as opposed to running it every hour? I mean, when people, let's just forget about the sensors and instead think about people uploading data when they get to the place where they can upload data, when they're not working offline. At that point, could you the aggregation on demand, basically, as new data comes in?
Because you only need to know what the aggregations are if someone's actually looking at them. So as soon as someone loads up the dashboards where they go, I want to look at these, then you can check in the database, have they computed, if not, compute them. But there's a little bit risk that no one looked at the dashboard for 30 days and then they open it and you've got to do a lot of work very quickly. And as we've seen, DuckDB, when running the browser, is not able to crunch large amounts of data. So what I think like the best setup to do is to, at some level, do the aggregations automatically. But obviously that's not going to have the most recent data in it as well. It's only going to have computed like yesterday's data. So anything that happened yesterday or before, you pre-aggregate. And when someone opens it up for a dashboard and they want to find out what is the latest data, we can take the historical data and append to it the latest data as fetched from Firebase in real time. So we can append real-time data to the historical data, and that way the dashboard will reflect the freshest data possible. And that's called the Lambda architecture, where you combine this batch process with a streaming data source. We'll finish this work off, have the aggregation scheduled, maybe look at combining it with real-time data in a Lambda architecture, and then visualizing those real-time datas on the plot dashboard. So hope to see you soon. Thanks for listening. Thank you.